You're given, this is a calculator active problem, and you are given a graph, 2 plus cosine 3 theta plus sine of 3 theta, and we're only looking at this graph from 0 to 2 pi. And first question is, find the area of the region bounded by the graph of R and the lines theta equals 0 and pi halves. So in this case, they're actually giving us the bounds, 0 and pi half. We only care about that, and it's only one graph. So area of a polar is just 1/2 R squared, so 2 plus cosine 3 theta plus sine theta squared d theta, and my bounds are 0 to pi half. So we're going to use our calculator, and if you punch this out, you get 4.76032. Now the second one is where you're going to be looking at the graph only in the first quadrant that is outside the graph of 2 plus cosine of 3 theta plus sine of theta and inside the graph of r equals 3. So let's go ahead and look at these graphs on the calculator. I'm going to be using the iPad calculator, so it's going to look a little bit different. But so go to polar mode on your calculator and go ahead and let's look at this graph. So I have the equations typed in, the 2 plus cosine 3 theta plus sine theta and r equals 3. So if I look at the graph, and I'm going to go ahead and look on a trig window, notice that we're only looking in the first quadrant. So I'm only looking here. So it's going to be outside the graph of the green, that's the 2 plus cosine 3 theta, and inside the circle. So you've got a little piece that's outside the green but inside the pink in this first quadrant here. So remember, the first thing we need to do is find those points of intersection. So we're going to go ahead and do that in the calculator. But remember, points of intersection you need to do on the function mode. So you're going to go ahead and take this and set it equal to 3, make this y1, make this y2, and you're going to notice there are going to be 2 points of intersection here. One of them is going to be just starting at theta equals 0, which you could see from the graph anyway, but that's the first one, and then we want to know when does it intersect again. The other one is 1.5707 something. It's exactly pi halves. So if you look at the graph, okay, let's go back to our graph and think about what we need to do. So if I integrate the entire pink graph from 0 to the bound 1.57, you're going to get everything shaded inside the pink. And then what we're going to need to do is subtract off the area inside the green that will give us just the piece that we're looking for. So this is going to be 1/2, 0 to, I'm going to call this A just to make it easier, of the circle. And then I'm going to subtract off same bounds of, and I can just use R because this has been defined as R. And then I will get that little sliver piece. And if you punch this in your calculator, you get 2.3825. Okay, lastly, part C. Somewhere between 0 and pi half, there is one point P on the polar curve with an x-coordinate of 2. I want to find the angle that corresponds to that point. Well, we're talking about an x value, but I need to find an angle. So we need an equation that has x's and thetas in it. This is where we're going to use this conversion equation. X equals r cosine theta. I know x is 2. My r is my r equation for this problem, which is 2 plus cosine of 3 theta plus sine theta. And then I still have that cosine. And I need to find the angle theta. I'm going to just solve this in the calculator. y1, y2 in function mode. And I'm looking only for number between 0 and pi half, so set up your window. So theta happens to be 0.57690, something like that.